Hello again. Congratulations on your success in the first section. In this video, we will remember the process of solving a first-degree inequality. That is, all those steps we take in a first-degree inequality to bring it to the simple form we saw in the previous section. For example, x greater than -7. This figure on your screen shows which numbers verify it. So they are called solutions to the inequality, such as the -6, which is within the solutions.
It also shows which numbers are not among the solutions, like the number -8, but also -7 itself. The process of solving first-degree inequalities, as you may recall, is very similar to solving the first-degree equations. Now let's remember the main process of resolving a first-degree inequality.
First, we find the least common multiple of the denominators, also called least common denominator, or LCD. If you already know how to do this, go to the next step. Following the tip written below, I will now remind you how to do this. Typically, we break one by one the denominators into a product of prime factors. 3 is a prime number, 6 equals 2 times 3, and 4 equals 2 times 2. That is, 2 raised to the power of 2. Then remember, the LCD is the product consisting of common and non-common factors. In the largest exhibitor each one is appearing. So LCD equals 2 in the power of 2, times 3, which equals to 4 times 3, equals to 12.
But how do some people respond so quickly that the answer is 12? Do they do all that so fast? No, this procedure is for larger numbers. Practically, we are doing this. We are checking the largest of the 3 denominators, number 6 in this case, as an LCD candidate. As 6 equals 2 times 3, it's already a multiple of number 3, but 6 is not a multiple of number 4. Then we try the next multiples of 6, 2 times 6, 3 times 6, and so on, until we get the first multiple of 6 that can be also divided by number 4.
Then we multiply 12 by all terms of the inequality. The inequality has 4 terms divided in its 2 parts, so we want 4 12s, 1 for each term. 12 times the first term, 12 times the second, and so on. As we said, 12 is multiplied by all 4 terms, but 12 is not used to be multiplied by the numerators. It is used to be simplified with the denominators and eliminate them. So, it is simplified with the first denominator, number 3. That is, they are both divided by 3 and the denominator becomes 1, so it is eliminated, while 12 becomes 4. Similarly, to the other fractions, 12 is simplified with the second denominator, number 6, and becomes 2. It's simplified with the third denominator, number 4, and it becomes 3.
Then we write the inequality simplified, putting parentheses, no brackets where needed. In the numerator of the first fraction, we had one term, a product of 2 times a parenthesis. So we don't need to put another parenthesis, that is, brackets. So we just write 4 times 2 times the parenthesis, or straight 8 times the parenthesis. In the second fraction, we have 2 terms, or a sum of 2 terms, x plus 1. So this must be put in a parenthesis. In the third fraction, we continue like in the first one. 3 times 3, which is 9, times x minus 1 in a parenthesis.
What do we do if 12, or any LCD least common multiple, is completely simplified with itself as a denominator, and there remains number 1 to be multiplied with the numerator? Caution on this. If the numerator has 2 terms and there's a minus sign in front of the fraction, then we have to put the numerator in a parenthesis with the minus sign in front.
Then we multiply, using the distributive property, but caution again, minding the plus or minus signs. Plus 8 times plus x equals 8x, and plus 8 times minus 2 equals minus 16. Then pay attention. Minus 2 times plus x equals minus 2x, and minus 2 times plus 1 equals minus 2, then plus 9. Times the parentheses x minus 1, resulting 9x minus 9, and so on. Then we separate the known from the unknown terms. Whenever a term changes part of the inequality, its sign also changes. First, the unknown terms from left to right. 8x and minus 2's x remain in the first part, so we copy them with the same sign, while 9x of the second part comes in the first part and changes sign. It becomes minus 9x. Unknown terms end, so we copy the symbol of the inequality to start writing the second part.
Likewise, for the known terms, from left to right, minus 16 and minus 2 went to the second part and became plus 16 and plus 2. Just notice that 16 is the first term there, and the sign plus is not to be written. Finally, minus 9 and plus 12 don't change sign, because they stay in the second part of the inequality.
Then we add the like terms in both parts. We think 8 minus 2 minus 9 times x equals, and we write minus 3x in the first part. Then we copy the less, then sign, and then we add the positive terms first. 16 plus 2 plus 12 equals 30, and finally 30 minus 9 equals 21 in the second part. The inequality has taken the form a times x less than minus b, or in other cases greater than minus b.
Now is the time to divide both parts of the inequality by the coefficient of x, as long as it is not 0. We rewrite the two parts below without the symbol of the inequality between them. Then we divide them by the coefficient. That is, we denote the coefficient as a denominator in both parts, and if the coefficient is negative, we change the direction of the inequality sign. Otherwise, we leave it as is. These can be either written or done in our minds. One way or the other, we rewrite the inequality simplified. Minus 3 is simplified, and x remains in the first part, while 21 divided by minus 3 equals minus 7 in the second part.
Then we present the solutions on a number line, the axis of real numbers. We watched in a previous video that in the inequality x greater than minus 7, the minus 7 itself is not a solution. Minus 7 is the boundary between numbers that are solutions and numbers that are not, but it belongs to those that are not solutions. This is shown on the axis from the hollow circle and the line that does not go down vertically, but is slightly lateral to the side of the solutions. This helps in some cases when we search for common solutions between inequalities.
We also write the solutions in the form of an interval. Recall that in this form, the solutions are presented as follows. We say that x belongs to the open minus 7, plus infinite open interval. The word open and the parenthesis symbol indicate that the number minus 7 is not included in the solutions. With the infinity sign, minus or plus infinity, we always put a parenthesis, and therefore the word open can be omitted. That is, we can read x belongs to the open minus 7, plus infinite without pronouncing the parenthesis.
But if the coefficient of the unknown x is 0, in theory, a equals to 0, and the second part of the inequality is not, b differs from 0, then the inequality is either impossible, meaning that it has no solution, or indefinite, also called identity, which means it is verified by all real numbers depending on the sign, plus or minus, of the second part, but also depending on the direction of the inequality sign. We check its truth, as we've learned in the previous chapter, and we decide accordingly. If it is true for every value of x, then it is an identity, otherwise it is impossible. If both the coefficient of x and the second part are equal to 0, so both a and b equal to 0, then the inequality is impossible or indefinite, also called identity. depending on whether it is a pure inequality or not.
Let's suppose now that by solving an inequality, we result at x less than or equal to 3, then 3 is included in the solutions, and this in the axis is shown by the full dot and the vertical line that then turns to the side of the solutions. The corresponding symbolism for the solutions interval is the square bracket, which is rendered colloquially by the word closed number interval. That is, we pronounce x belongs to the minus infinite, comma, 3, closed interval. As you can see, we do not read the round bracket, parenthesis, of the infinite sign as open, since that goes without saying. Now, if we were in class, you would ask me your questions. You can use the discussions forum or wait until we meet. Keep up the good work. See you soon. Until the next video. Bye!